So the IRIG-B Analyzer is really good for detecting faults in our IRIG-B cabling. So traditionally, a service person would come along with a multimeter and try to determine what was wrong with their IRIG-B cabling. And with a multimeter, you only get very basic information, which tells you, is there a signal present or not? It doesn't tell you anything about the signal at all. So if I was to fire up my IRIG-B Analyzer, for instance, I'd be able to detect, have I got an IRIG-B signal? Is it complying with C37118.1 extensions? Have I got the polarity right? Is the voltage level correct? And all of these different measurements which are going to help us more accurately and faster to debug our IRIG-B installation. So if I was to give just a very quick example, I have here an NTS03G Plus, and these two ports, P10 and 11, can be configured for DC level shift or AM IRIG output. And you may have a simple fault where somebody has configured one for AM when it should be DC level shift. Now, your multimeter is not going to be able to give you that information. If I was to connect my IRIG-B Analyzer, it immediately tells me here that P11 was amplitude modulated. I've got my polarity correct. It's going to give me my date and time and the standards to which I'm conforming, C37118.1. And it gives me the voltage levels, showing that I have adequate voltage levels. And if I scroll all the way down, I get my local time offset, and my time quality is 0, which means that this clock is synchronized, UTC traceable. So if I was then to go and look at P10, which is the other port, and in this case, someone has put the switch to DC level shift IRIG-B. And you can see here the type is showing up, DC level shift, and we get all the same information. Polarity non-inverted, your date, your time, your signal quality, your voltage levels, etc., etc. So, another mistake might be that somebody has the polarity incorrect. So if I just swap my multimeter probes around here, it'll again detect the signal. It'll still read it correctly, but it's bringing up in bold here, polarity inverted. So we know that we've got either our leads the wrong way around, or somebody has wired it incorrectly. I've also set up here an example of an older TCG02E, and this one has a 25 milliamp output, and I've put on here a 120 ohm resistor, which means that I'm drawing about 60 milliamps from this port. So I'm really overdriving this port. So that's very difficult to tell with a traditional multimeter. But if I use my IRIG-B Analyzer, I'll be able to tell everything about this port. So here it is. It says that I'm getting DC level shift. They're telling me the polarity is inverted. That's because I've put my multimeter probes on inverted. It'll tell me down here, interestingly note that it's only complying to C37118, not 118.1, because this is an older clock, and that my amplitude was 4 volts. And so if you're not getting synchronization, you might want to check to see that the devices you're supplying required greater than 4 volts. This clock also had a time offset of 8 hours, which is not correct for New Zealand, which may be another fault that you could detect. You'll note that I'm getting the time quality 0, which is UTC traceable, synchronized, but I don't get the continuous time quality, which is the information you get from C37118.1. The final thing, or an additional feature of the IRIG-B Analyzer, is that we can also detect fiber optic IRIG-B. So traditionally, if somebody was wanting to check that their fiber optic was working, they might try and steer down the end of the lead. Not really best practice. So here I've got 2 fiber optic signals, and one of them is going to give me IRIG-B. So, and the other is going to give me fiber pulses. So here I've plugged in the The pulses, if I switch over to the IRIG-B, there, now telling me I'm getting unmodulated fiber optic. And again, it tells me all the same information, that the polarity is correct, the date and time, C37118.1. So we know that that one is good.